So welcome to our first video. This video is going to cover what an algebraic expression is and where it comes from and some of the vocabulary involved in the algebraic expressions. Also how to evaluate them and give their value. Let's get started. So an algebraic expression is a way to express a mathematical idea. It's kind of like a sentence. We would call maybe an equation a sentence, but an expression is kind of like part of a sentence. It's kind of a statement. It uses numbers, so 2 or 1/2 or decimals, operations like times and division, multiplication, subtraction, a lot of fractions, decimals, and variables to give information. So a variable is like a letter that might represent a quantity that's either known or unknown. The expression usually represents a situation. So a situation here might be Simon. He saved up $23.50 so far. So, this would be an important piece of information right here. $23.50. He has that much money, and he's going to start working at a job that's going to pay him $12 per hour, right? So we want to write an expression for the money he has after working H hours. That's our variable right there. So H is what we would call a variable, and it's going to represent the number of hours he spends at his job. So let's see what the expression might be for this situation. So this is the expression. You can see it's 2350 plus 12h. So why is that? Well, the 2350, clearly that's coming from the very first information we had. So 2350 is what we call a fixed amount, right? He has that much money so far. So there it is, right there, first thing in the expression. And it comes first. If you read it first in the sentence, it's going to come first in the expression. That's just good form. 12 per hour. So that's the next part. The $12, you see that here. And per, as we talked about kind of in our unit on percentages, that's for every hour. So we have a multiplication here. It's $12 times the number of hours. Sometimes we'd use a dot right here as a dot. I might try to put the dot in there, but we usually leave it out. It just means multiplication. So however many hours, we're not sure how many hours he's worked, but $12 for every hour, so 12 times h. If h is 2, of course, 2 times 12 would be 24. And then we could find $24 is what he made at his job, plus the $23.50. That would give us $47.50. We'll get to that more later. That's evaluating an expression, and that would tell us how much money he had. One other things you might notice is that this dollar sign here, we don't really include that in the expression. It's a little bit awkward to include a dollar sign in the expression, so we just kind of leave that out. So let me just get rid of these. 2350 plus 12h. Let's move on. So terms. Expressions are made up of terms. An algebraic expression is a collection of terms. In the last expression we just did, we saw that 2350, so that was one term, and then the 12h, that was another of the terms. So each term can either be a constant, what we call a constant term. The 2350 was the constant term because it's just how much money he started with, and then the variable term was that 12h. It has a letter in it. So the expression, again, it represents a situation. So let's look at some terms. Some constant terms, right? These are going to just be, no variable. If you look at all of these terms, they don't have a variable at all. And variable terms just have letters in them. So again, a variable is a letter that represents some number that may or may not be known. So 5x, negative 6y, positive 2/3 z, negative 0.6 times w. Those are variable terms. In general, Terms are separated by plus or minus signs, and they include the sign right before them. So we're going to look at how to kind of chop up expressions and see what their individual terms are on the next slide. So looking at this expression, identifying the terms. So our expression is negative 3x plus 6y plus 10. You might think about how many terms are there? How many do you see? And what are the variable terms and the constant terms? So think about that for a second. How many terms in the expression and what are the variable and constant terms? So let's see, there's 3 terms. Our first term is negative 3x, negative 3x. So that is right here, circling it. You see it includes the negative sign in the front. Terms are separated by plus and minus signs. So the 6y is next, but it includes that positive sign in the front, plus 6y there. And finally, the 10, positive 10, that's our third term. So we have 3 terms. Which ones are variable terms and which are constant terms? Let's see. 2 variable terms, they do come in the front, so negative 3x has a variable, which is x, and positive 6y, those are our variable terms. Constant term is positive 10. So 2 variable terms, 1 constant term, and again, the 10 is not changing. So we say, we know it's 10, we call that a constant. The 6y, that could be anything. I mean, if y is 2, again, 2 times 6 is 12. If y is 3, 3 times 6 is 18. So we're not totally sure what the value of that is yet. That's why we call it variable. So the other thing that we say is in an expression is pretty important is the coefficient. That's a multiplier. Coefficients are usually the numbers we see in the variable terms. So it appears before the variable. And if a variable is kind of just by itself and we don't see a number right next to it, then the coefficient is 1. So as we're looking at this expression, we have negative 3x plus y plus 5/2 z minus 10. We would think about these first 3 terms have coefficients. So what are the coefficients of x, y, and z? Well, what's the coefficient of x? We look right here, and the number in front is negative 3. It's the multiplier. What is the coefficient of y? Well, this is the tricky one. If it's missing, it's not 0. If the variable's there, it's got to be 1 or negative 1 if it's a negative. So the coefficient of y is 1. The coefficient of z, again, what's in front? 5/2. So the coefficient of z is 5/2. Last question, what's the coefficient of negative 10? Well, it has no coefficient. That's because it is a constant term. So we don't really say that a constant term has a coefficient. Again, a coefficient is really a fancy word for just a multiplier. It means to multiply by something. So whatever, again, whatever x is, if it's 10 or 9 or 8, we're going to multiply that by negative 3. So negative 3 times 8, that would be negative 24. And then we would know the value of that term. Okay, so some vocabulary that we have learned so far. Let's see if you can figure out some of these vocabulary words. Options here. So an algebraic expression, what is that? Is it a collection of terms? Is it the multiplier of a variable? Is it a term that includes a letter for a variable? Is it a term with no variable? or are these separated by plus or minus signs? Take a second, see if you can match each of these vocabulary words to their definition. So let's see, algebraic expression, that is a collection of terms separated by plus or minus signs. Terms themselves are separated by plus or minus signs. So an algebraic expression is made up of terms. Constant terms, well, those are terms with no variable. Variable terms include a letter for a variable. And the coefficient is the multiplier of the variable. So good job matching those vocabulary words. So we did some basics, right, about what an expression is, where it comes from, and what some of the terminology is. Now we're going to look at how to evaluate them, how to find their value, because that's often what we want to know in math is, what an answer is. Some people just call it an answer, but evaluating. And then also to translate some situations into expressions. So let's have a look. To evaluate an expression, you're going to use some known values. So hopefully you're going to get some values. Say x, we don't know what it was, but now we know it's 5. So we're going to use 5 in our expression. We're going to get those values, multiply them by coefficients, and find the sum of all the terms. So example, what is the value of negative 3x plus 1/2 of y plus 10 if x is negative 2 and y is 6? Let's see how we would evaluate that expression. Here's the example. What is the value of negative 3x plus 1/2 of y plus 10 if x is negative 2 and y is 6? So we want to write the steps when we're evaluating expressions. It's pretty important. You can make mistakes. It's kind of like the order of operations. The very first thing that we would write is the expression itself. So here's the expression. On the left, we're going to see the mathematics, and on the right, we will see what we're doing. So here's the original expression. We're going to write that down first. The next step is to look at our values, negative 2 and 6, and to go ahead and write those in. So we call this substitution, substituting the known values. So you see here that x used to be just x. We didn't know what it was, but now we have substituted its value, negative 2, in parentheses. Similarly, y used to be, well, unknown. It's a variable, but now we've used 6 in parentheses. So those are our known values, called substitution or changing from what a letter was now to a number. At this point, we have some mathematics. So we know we're going to multiply the coefficient, negative 3 times negative 2, and find out the value of each of the terms. So, negative 3 times negative 2 is 6, positive 6. Check my mathematics. Half of 6 in the next term is 3, and 10 is still 10. So we had these 3 terms. We still have 3 terms. And the very last step is we just want to add everything up. These are all positive numbers. Sometimes there's negative numbers, but add those up, you're going to get 19. And that's your final answer. That's the value of the expression. So this is what we mean by evaluating. And again, it would be the same number of steps every time. Basically, we have those 4 steps. We have the original expression, just as written, the expression with the substituted values, multiplying the coefficients to find the value of each term, and then adding them to get the value in the end. So another example, just to see if you can do this one on your own. Got some decimals and fractions here. What is the value of 16a minus 4/3 of b plus 2.2 if a is negative 5/2 and b is 1.2? So let's see some steps here. Here is our original expression. Here is the substituted values. Again, A was -5/2. Let's see if I can underline that here. A is -5/2, and now we've got it right there. Can't see the yellow very well. And B was 1.2. And we see that here in parentheses for B. So again, checking my math, making sure everything looks good in parentheses. Multiplication, so 16 times -5/2 is -40. It's a negative number. 16 times 5 is 80. Divide that by 2, you get 40, but it's negative. 4/3 of 1.2 is 1.6. Again, a negative sign here, so it's negative. And our 2.2 is the constant term, so that's still 2.2. Sorry, this gets cut off, but multiply by the coefficients to find those values. Still three values of 3 terms. Then we want to add these up. So still -39.4. Again, you want to find the value of those 3 terms. So -40 and -1.6 would make -41.6. And then you add 2.2, you would get -39.4. So see how you did? Hopefully you got the value of that expression. But we are going to use decimals and fractions quite a bit in our work with expressions. So the last topic here in chapter 4.1 is just writing expressions. And this is kind of like translating. It's kind of like being, someone who has to interpret one language and turn it into another. So we're reading English paragraphs or sentences, and we're kind of a math translator to translate those into mathematical sentences. So let's see, at a museum, adult tickets cost $17.50. and student tickets cost $9. What is an expression for the total cost of A adults and S students? So we got some important things that we should highlight here, right? We know that adult tickets cost $17.50, so I'll just highlight adult and $17.50. Student tickets cost $9. And then we're asking for the total. That's an important math word, right? Total means sum or adding together. And we are given some variables. One of them is A for adults and S for students. Excuse me. So typically, a lot of expressions have multiplication in them, right? If you have adults costing $17.50 and you have 2 adults, you're clearly going to multiply 2 times that number. Or 10 adults times that number. So there's going to be multiplication involved. That's where those coefficients come in. If you have a number of students, 5 students, you're going to have to multiply 5 times 9. We don't know the number of adults or students, so that's where the variables come in, but we're still going to show multiplication using coefficients. And also this idea of total, that's going to be a sum, that's going to be addition. So let's look at what this expression, let's see what this expression is going to look like after we've done our translating. It's 17.5a plus 9s. Where is that coming from? Well, again, how many adults? We don't know. But we do know that each adult costs $17.50. So that's where our multiplication comes in, 17.5a. Again, you'll notice that I took off the $sign, but we are indicating multiplication. So whatever number of adults we have, we're going to multiply that. That's why it's next to this coefficient. And then coefficient of 9 times the number of students, and then the plus sign to indicate total, adding them all up. And this would be some amount of money that would represent the cost of all of those adults and students going to the museum. One more final example about writing expressions, changing them from words, English words, into mathematical symbols. So here's a pretty sizable paragraph, but I'm going to read through this and see if we can figure out how we would translate it, do some translation work. Annabelle bought 2 packs of markers. So we might highlight 2 as we go. There's 2 different packs of markers. She used half of the markers from the first pack. So again, half, that's a mathematical idea. She's using half of the markers from the first pack in her art project and 2/3 of the markers in the other pack. So maybe, she's picking certain colors, but we have these fractions, half of the first pack, 2/3 of the second pack, as well as 5 other markers, so from somewhere else that she's using. If there were m markers, so here's a variable, m markers in the first pack and n markers in the second pack, what is an expression for the total number of markers she used in the project? So that's a mouthful, right? There's a lot going on there, but we're trying to highlight and pick out the various important parts and mathematical terms. And again, I hope that you notice that this is going to be a total situation, right? We want to add things together. So we have some amount of markers in one pack, some amount of markers in another, and then these additional 5. And we're going to put all that together. But we still have to say, where is m in this expression? Where's n? And where are these 2 fractions, half and 2/3? So think about this for a second. How would you write this as an expression? And then we'll see what it looks like. So here's the final expression, m over 2. So where's that coming from? Well, m is the number of markers in the first pack, and she used half of them. So half in an expression is almost always written like this, divided by 2. So we use fraction bars when we're writing expressions. We don't use the division symbol. We could have written it as 1/2 times m, kind of like the next term here. But usually dividing by 2, that's how we would show half of m. 2/3 of the markers in the other pack. So of is a word that typically means times. And it's really similar, except with 2/3, we're going to put that in front. So this says 2/3 of the markers in the second pack. Those are how we're using the fractions to indicate parts of those 2 packs of markers. And then the 5 at the end is the easy part. I don't know, she had 5 markers lying around somewhere and she also used those. So we're just going to add that to the end of our expression. Again, we've been using plus because both of these examples have total numbers of things, total amount for the tickets at the museum, or total number of markers used. But there could be subtraction involved. There could be other operations involved. So it can be tricky when you're interpreting sentences. You want to read them out loud. You want to read them twice. You definitely want to highlight or reorganize information. You might take some notes and say, how can I write this as an expression? And another thing is to kind of check it, throw some values out there. What if her first pack of markers had 10 markers in it? What if the second pack had 12 markers in it? You could check your expression using those numbers to see if it comes out to be what you expect. And we're going to do some more of that as we make it through the unit. So thank you for watching the first video about expressions, what they're made up of, the vocabulary words, how to evaluate them, and also how to translate them from English words. I hope that you learned what you needed to, took your notes, and good luck working on your 4-1 assignments.